You've seen it, right? AI can now whip up these absolutely mind-blowing, photorealistic images from just a few words. It's incredible. But then you look at AI video and something's just a little bit off, isn't it? Well, get ready because the next big leap in AI creativity is officially here. And today, we're going to pull back the curtain on the secret engine that's about to change everything.
So let's just get right to the heart of it. Why is there this huge gap? You can type a prompt and flawlessly edit a photo, but when you try that with video, you often get these glitchy, kind of uncanny results. Well, the real problem is keeping things consistent over time. In a video, objects can flicker in and out of existence, faces can morph, and that's because telling an AI to maintain one single coherent vision across thousands of individual frames is an unbelievably difficult task.
And this really spells it out perfectly. I mean, on one hand, AI image editing, it's mature, it's precise, it just works. But the second you introduce the dimension of time, you run into this brutal challenge called temporal coherence. See, it's not about editing one perfect picture anymore. It's about editing, say, 30 or even 60 perfect pictures per second and making sure none of them are out of place. And that's where things have always traditionally just fallen apart.
Now, you might be thinking the solution is just, more power, bigger models, more computers, right? But the real bottleneck here isn't the engine, it's the fuel. The problem is way more fundamental, and it all boils down to one thing: data.
Okay, so this is the absolute key. To teach an AI how to do this properly, you need something called paired data. That means you need three things for every single example: a before video, the text instruction for the change, and a perfect after video showing that change. Now, a simple prompt like "make the car red," that's one thing. But what about something complex, like make the actor look 20 years older while keeping their identity perfect and accounting for all the subtle lighting changes as they move? Trying to create millions of those by hand? It's basically impossible, a total non-starter.
And we're not talking about a small library of examples here. To get the kind of quality that we all expect, an AI needs to learn from over 1 million of these perfect before and after clips. A dataset with that kind of scale and that level of quality for complex video edits, it just flat out did not exist. Until now, that is.
And this is where the real breakthrough happens. Instead of trying to find this impossible data set out in the wild, a team of researchers decided, what if we just built it ourselves? Enter the Ditto pipeline. This thing is an absolutely groundbreaking framework designed from the ground up to create the perfect training data and to do it on a massive scale.
And you gotta love the name, right? As the researchers point out, it's chosen for a reason. Ditto is all about making the final video a perfect, faithful copy, a ditto, of what the user asked for. It's just such a simple, elegant name for a really elegant solution.
So how does this incredible data-making machine actually work? Well, the best way to think about it is like a master chef teaching an apprentice. First, a super advanced image AI edits just one single frame to perfection. That's like the photo of the finished dish in a cookbook. Second, a video generator takes that photo for the final appearance and uses the original video's motion as the recipe to cook up the entire clip. And finally, you have an automated AI that acts as quality control, checking every single video and tossing out any that aren't absolutely perfect. Just to give you a sense of the sheer scale of this operation, get a load of this number. Building the final dataset, which they call Ditto 1M, took over 12,000 GPU days. Now, what does that mean? Well, one GPU day is like taking a powerful graphics card, the kind you'd find in a high-end gaming PC, and running it at full blast, non-stop, for 24 hours. So we're talking about an immense amount of computer power dedicated just to creating the textbook.
So, with this unbelievable, one-of-a-kind dataset finally in hand, the stage was set. For the very first time, researchers could properly train a truly next-generation video editing model. They named it Editto, and believe me, it is a genuine game-changer.
But this created a brand new, fascinating puzzle. Remember, all that amazing training data was made using a visual cheat sheet, that single edited frame. The final AI model, though, it's not going to have that luxury out in the real world. It has to produce the same incredible result using only a text prompt. So the question is, how do you teach a model to make that leap from a visual example to just an abstract instruction? Well, they use this super clever training wheels approach. In phase 1, the model gets to see both the text prompt and the visual guide. Total hand-holding. Then, in phase 2, they start taking the training wheels off, occasionally hiding that visual guide. And by phase 3, the wheels are completely off. The model only gets the text prompt, forcing it to figure out that deep connection between language and visual changes all on its own. Okay, so after that whole incredibly complex process, what was the payoff? What can this new model actually do? Well, the results set an entirely new standard for what's possible. It's a new state-of-the-art.
Let's just look at the results. The prompt is simple. Make it the Lego toys style. This is a massive global change to the whole video. And just look at the details. The plastic reflection on the car, the blocky texture on the trees in the background. Every single element is transformed, and more importantly, it stays consistent, frame after frame. No flickering, no weird artifacts, it's just perfect. All right, now let's look at a super precise local edit. The prompt: replace the black dog with a white fox. Check out how the model doesn't just swap the animal, it understands the entire context of the scene. It leaves everything else, the person's leg, the grass, the lighting, completely untouched. It even nails the subtle way the light and shadows play on the fox's white fur. It's seamless.
And this is where it goes from just being an editor to being a true creative partner. Reimagine the industrial setting in a cybernetic brain lab. I mean, this isn't just a simple style filter. This is a complete conceptual reinvention. You see the pulsating lights, the futuristic machinery. It's a whole new aesthetic, but it still keeps the original motion and structure of the video. That is some serious imaginative intelligence at work.
And look, these aren't just a few cherry-picked examples that look good. The hard data is seriously compelling. When real people were asked to score the overall quality of the edits, Editto crushed it with a score of 3.86 out of 5. Compare that to previous methods, which were way down at 2.36. In head-to-head matchups, people overwhelmingly said the results from this new model were just better.
So the tech is obviously super impressive, but let's zoom out from the research paper for a minute and talk about what this means in the real world. Why does this breakthrough actually matter to you, whether you're a YouTuber, a filmmaker, or just somebody who loves to create cool stuff? Because this is way more than just a new feature in some software. It is a fundamental shift. We're talking about democratizing visual effects that used to require a Hollywood studio budget and putting them in everyone's hands. It means making workflows for artists radically faster, turning what used to be days of tedious work into just a few minutes. And honestly, the most exciting part? It lays the foundation for completely new ways to tell stories, empowering a whole new generation of creators.
This kind of power is coming, and it's going to be in the hands of creators everywhere, sooner than you think. The future of video is literally being written as we speak. So, I guess there's only one question left, and it's for you. What will you create with it? Thanks for watching.